All right, so we've got our title of our notes today. Composition of functions. Okay, we're not going to actually get to the composition part till later, but that's just kind of our title of our notes. Okay, like I said, we'll start a little slow. Make sure that you remember the skills that we've learned before so that we can use those skills today. All right. Let's start off with f of x equals 2x. Why are you talking to me, Siri? I'm not even talking to you.
Okay, give me a moment.
No, I won't give you a moment. You just stop talking to me. Rude. 2x plus 5 is f of x. G of x is x plus 4. Okay? So first of all, can you tell me what f of 2 is? We've done this before. It's been a while. What used to be here? An x. What's there now? So when I rewrite my f of x, what should I put instead of an x? A 2, right? So 2 times 2 plus 5. Does anybody remember what 2 times 2 is? I was just joking about that. Okay. So 4 plus 5, f of 2 is 9. We good? Could you tell me what g of negative 6 is? Well, negative 6 plus 4. G of negative 6 is negative 2. See, I told you we'd start off easy. Still okay with me? All right. Let's go here then. F plus g of x. What do I do with that? Add them. 2x plus 5 plus x plus 4. That's f of x. That's g of x. It's asking me to add them. So, add them. What do I get? 3x plus 9. Done. Remember doing that? What about g minus f of x? What do I do? Subtract them. Which one do I start with? G, because it comes first right here, correct? So I have x plus 4 minus 2x plus 5. What is x minus 2x? Negative x. What is 4 minus 5? Done. Remember this? Is anyone remembering any of this? Oh, good. Lots of nods. Okay. What about this one? F times g of x. What should I do with those? Multiply them. What's f of x? 2x plus 5. Good. And what's g of x? How do I multiply them? What's it called? Distributive property. Good. What's 2x times x? 2x squared. What's 2x times 4? 8x. What's 5 times x? 5x. And what's 5 times 4? 20. Why did I write it the way I did? Because I remembered that these are like terms and I can go ahead and combine them, so I wrote them close to each other. So I'd remember, I have one more step, 2x squared plus 13x plus 20. What's the last one I'm going to ask you about? F divided by g of x. What is it? F of x is 2x plus 5. G of x is x plus 4. Done. Nothing to simplify, is there? So we're done. Okay? Questions? So you've seen all that already, haven't you? We did that last semester. Okay? So now I'm going to ask for this. Fog, right? We actually had fog. Yes, ma'am.
Can you send Samantha Hodge to the office, please?
Does she need to come right now?
Whenever it's possible.
Okay, thank you.
Thank you.
We had fog this morning. That's not what kind of fog we're talking about. No, 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 no. Okay? This is saying f of g of x. How do we read this one? F of 2, right? If this is saying f of g of x, I could also write this like this. Right? F of g of x. How did I find f of 2? Well, it used to be f of x, right? So anywhere there was an x, I put in a 2. How do you think we're going to do this? Anywhere there's an x, plug in the g of x. That's exactly right. Okay? So I'm going to write this down real quick just so we remember. I know you have it on your paper, but I don't have it up here. What is this, x plus 4? Okay. So I start with f. F of g of x. I'm going to start writing f. 2 times, am I multiplying it times x anymore? What am I multiplying it by? G of x plus 5. But wait, don't I know g of x? What is g of x? X plus 4 plus 5. Wow, that looks like something Jennifer could do. Right? My Jennifer? 6th grade? Right? What's 2 times 4? 2 times x? 2x. What's 2 times 4? 8 plus 5. Do we know 8 plus 5? Good. 2x plus 13. Done. It is pretty funny. Jiminy Christmas. Any questions on this? You okay with it? Anywhere there was an x, I put in a g of x, but I realized I knew what g of x was. It was x plus 4, so I substituted in the x plus 4 and simplified it as far as I could. So could you do this? You could say golf if you want. It's not the sport. Sport's way harder than this. What's it the same as, do you think? G of f of x. Why am I showing you these 2 ways? Why don't I just show you one way and be done with it? Guess how it shows up? Both ways. Shows up both ways. I want you to be aware of what they mean and the fact that they are the same. Equivalent, equal. Okay? So if we're finding g of f of x, what do I start with? Yeah, I start with the g, right? Start with g, which is x plus 4, except I can't write I can't write x. What do I write instead? F of x plus 4. Because anywhere there's an x, I want to write f of x. Well, there's no multiplier or anything right there, so I'm just going to write f of x. However, we know f of x, don't we? What is it? 2x plus 5 plus 4. which equals 2x plus 9. Did you expect them to be the same? I see some nods and some people shaking their head. Okay, just asking a question. Sometimes they're the same, sometimes they're not. Okay? Guys, this is called composition of functions. This is the whole focus of our notes for today. Okay? So first I teach you how to do it. Everybody understand how to do composition of functions? Fogg and Goff. We clear on that? Now let me show you what it's used for. All right? Excuse me. Yesterday, these were two functions that we had. Oh, I have to show you something else too while we're at it. 2x plus 5. That's something new, isn't it? What's new? This thing? The notation, right? If I'm telling you, you already know what it means. Do you have any guesses of what it means? What did I refer to? Where did we talk about this? Yeah, yesterday, right? I said we talked about this yesterday. I gave you a function and I gave you this function. How are these functions related? Yeah, they're inverses. Okay? We found these yesterday. If you look back in your notes, they're actually there. This was a function that was given. We switched x and y, and we found the inverse. So guess what this means right here? Inverse. This is the mathematical notation saying this is the inverse. Okay? For argument's sake, we're going to call it g of x. Okay? Because we got to do Fogg and Goff. And the -1 thing, it doesn't help us out right now. Okay? I just need you to know that that is a mathematical notation that implies inverse. Okay? So I want to do f of g of x with these two functions right here. Okay? So I'm going to start with f. I'm going to write 2. I'm not going to write x. What am I going to write? G of x plus 5. But I know g of x. It is x minus 5 over 2. So 2 times x minus 5 over 2 plus 5. How do I simplify that? This is multiplying by 2 and dividing by 2. What happens to the 2's? It's 1, right? That's a 1. So I just get x minus 5 plus 5, which equals what? X. Okay, that's nice, right? Nice, easy answer. Let's do g of f of x. So I start with g, start with this one. I don't want to write f. Excuse me, I don't want to write x. What do I want to write? F of x. F of x minus 5 over 2. But I know f of x, which is 2x plus 5, and then the minus 5 over 2. Any suggestions? Yeah, that's 0, isn't it? Plus 5 minus 5, that's 0. 2x divided by 2. Yeah, x. How did we find inverse functions yesterday? Absolutely. We switched the x and y. And then we solved for y if that was necessary. When we graphed them, what did we graph? The function, its inverse, yeah, and y equals x. What did we just find right here? Y equals x. Is that important? So important. I just proved without a shadow of a doubt that these two functions, even though I told you they were inverses at the beginning, I just proved to you that they were. Because when I do composition of functions, f of g of x and g of f of x, both times they equaled x. It's not that they equaled the same thing, it's that they equaled x. They equal that line on the graph, that imaginary line that we put there, what the functions reflect across to give us the inverse. Okay? So 2 of the problems on your homework tonight say, find f of g of x. Great. Go find it. 2 of the problems on your homework tonight say, verify that these 2 functions are inverses. How are you going to do that? Yeah, exactly. You have to do f of g of x and g of f of x. Most of the time. Yeah, I always have to screw it up, right, by saying most of the time. This is not a screw up. This is actually easier for you. Okay? If you do if you do f of g of x and get like x plus 2, do you have to do g of f of x? No, why not? Because you already know that they're not inverses. In order for them to be inverses, what do both of these have to equal? X. So now you see what I mean by most of the time? If you do f of g of x and you get x, go do g of f of x. As long as you get x, then they are inverses of each other. Does that make sense? Okay? So you're going to end up with 12 homework problems tonight. Okay? 2 of them ask you to add the functions. 2 of them ask you to subtract the functions. 2 of them ask you to multiply the functions. And, yes, 2 of them ask you to divide the functions. Okay? The last 4 homework problems are about composition. Some just specifically say, find fog or find f of g of x. When that's asked, when all you're asked for here, all you have to do is find this. It doesn't matter what you get. It's just saying, can you find a composition of functions? But the last 2 say, verify that these 2 functions are inverses. And when you're asked to verify, you have to do both directions, f of g of x and g of f of x, or fog and goff. Okay, any questions?